Hello friends, welcome to a new concept explain class. Today's class is important because I'm going to teach you what is relative humidity and how this is related to dew point, and what is dew point and how dew point is reached and what happens when dew point is reached. Okay, so both are interrelated. So let us understand that. Now I have chosen this topic because I have come across a lot of aspirants who are, though they know what is relative humidity, but they do not understand the mechanism. And because they do not understand this mechanism, they cannot understand what is the mechanism behind the condensation and formation of precipitation, right? Now let us start by understanding first how water vapor is held in air, right? So about 4% of air is made up of water vapor. But it is not fixed, it decreases. The highest amount of water vapor is present near the equator, and as you go away from the equator towards the poles, the amount of water vapor in air decreases, right? At the pole, the air is very dry, so the amount of water vapor is very less. So how water vapor is held in air? As you know, air consists of different substances. For example, there are molecules of oxygen, and there is nitrogen, there is carbon dioxide, argon, and other trace gases. It also contains dust particles and other aerosols, right? So there is a space between these molecules in air, right? So water molecules are held in this space. For example, here there is a space, here there is a space, here there is a space, right? So water molecules are held in this space. Now, one thing I want to explain next is what are the factors on which the capacity of air to hold moisture depends, right? For example, let us assume that this is the atmosphere, right? And it contains certain amount of water vapor, right? Now, what is it that we must do in order to increase the capacity of this air to hold more moisture, right? So let us understand that. Now, the water holding capacity of air is directly proportional to temperature. And this is very important. Pay close attention and understand this once and for all, right? So what happens when the temperature of any given volume of air increases, right? So as you know, whenever you heat something, whenever you supply energy to something, the molecules present in that substance start vibrating faster and faster because they are gaining energy, right? So when they gain energy, they move away from each other, right? For example, when you supply heat or energy to this water, molecules will start vibrating faster and they want to go away from each other. And eventually, when the water temperature reaches 100 degrees centigrade, they start converting into moisture, right? So similarly, when a given volume of air is heated because of heavy sunlight, what happens is that these molecules of air like argon, nitrogen, oxygen, etc., they gain energy, right? And because of energy, they start vibrating and they move away from each other. Okay, so because of this moving away from each other, what happens? The space between these molecules increases. So the space present here increases, right? Because they are absorbing energy from the sun. So when the space between them increases, as I told you just now, how water is held? Water is held between these molecules in the space present between these molecules, right? So if the space between these molecules increases, right, then the water holding capacity of this air increases, right? Because the overall space is increasing, right? For example, this volume of air, after absorbing sun's energy, grows like this and becomes like this. Now tell me whether this has more space between the molecules or this has. Obviously, this one has more space between the molecules, and now this air can hold a lot of water, right? So what we can learn is that the amount of water that can be held in a given amount of air is directly proportional to temperature. Meaning, if temperature increases, then amount of moisture holding capacity. I'm not saying moisture increases because we are not adding any moisture here. The moisture holding capacity increases, right? So if temperature decreases, then moisture holding capacity decreases. So it is directly proportional to temperature. Okay, so here I'm giving you some analogy to understand it better. For example, before the temperature rise, this was the volume of air, and because the rise of temperature, the volume of air's capacity to hold moisture increased. As if this sponge holds water, which is less, but this sponge can hold more water, right? So the capacity to hold water increases. Or you can look at this analogy. For example, before the temperature increase, this was the size of the atmosphere. It can hold, let's say, 50 liters of water. But because of increase in temperature, the overall space available for moisture increased. So now this bucket size increased. Now it can hold around 200 liters of water, right? So this is what I mean when I say temperature is directly proportional to water holding capacity of air. So I hope you understood this. Because once you understand this, then it becomes very easy to understand what is relative humidity. So let us understand that. So let us understand what is relative humidity by understanding it through a simple analogy, right? Let us consider this bucket as atmosphere. Okay. Now, every bucket has certain capacity, right? For example, let's say this bucket has a capacity of 100 liters. What I mean is, now this atmosphere, this volume of air can hold 100 liters of moisture. Okay. Now let us say that the temperature currently is 40 degrees centigrade. Now, as I just told you, if you want to increase the water holding capacity of air, then you have to increase the temperature, right? Now let us assume that temperature is constant, which is 40 degrees centigrade, and the capacity of this volume of air or atmosphere is 100 liters. Okay. Now, let's say we currently this bucket has, okay, let's say 20 liters of water. Fine. Now, what is the water holding capacity of this bucket? 100 liters. And what is the current amount of water which is present in this bucket? 20 liters. So if we put 20 liters, that is the current volume of air which is, the moisture which is present in this bucket. And what is the total capacity? 100 liters. So what is the percentage of water which is currently present in this bucket? If we do this calculation, then it would be 20%. Right? So basically what I'm trying to say here is that this atmosphere's capacity to hold water is 100 liters. But presently this atmosphere has 20 liters of water. So basically there is 20% water in this atmosphere. Meaning, what is the amount of water present in the atmosphere compared to the total carrying capacity of that atmosphere? And it is expressed in percentage. And this is relative humidity. Why it's called relative humidity? We are comparing the present amount of moisture to the total holding capacity of the moisture. As I just told you, the total holding capacity of this amount of air is 100 liters. So 100 liters can be placed in this bucket or this volume of air or this amount of air. But how much is the water which is presently there? It is just 20 liters. So you can say relative humidity is 20%. Let's say because of evaporation, the amount of moisture increases in this air. Now what happens? Let's say this, because of moisture added to the atmosphere, now this atmosphere has around let's say 50 liters of water. Okay. Now whether relative humidity increased or not, what is the current amount of moisture in this atmosphere? Okay, so it is 50 liters. What is the holding capacity? It is fixed, right? Because the temperature has not increased. The temperature is still 40 degrees. We are not increasing the temperature. So at this temperature, this atmosphere can hold 100 liters of water. So we have to put 100 liters here. Right now, the relative humidity is 50%, meaning 50% capacity is occupied because the carrying capacity is 100 liters and this atmosphere or this bucket is representing the atmosphere. So it has 50 liters of water. meaning against the total capacity, which is 100 liters, how much water is presently there? 50 liters, right? So the relative humidity is 50%. Now, you might ask me the question, why are we even calculating the relative humidity? Right? What is the significance of relative humidity? The significance of relative humidity is that while we are looking at the atmosphere, we want to know when it is going to rain, and we need to predict the rainfall, right? And one of the best ways to predict the rainfall is look at relative humidity. Why? Because if the carrying capacity of this atmosphere at this temperature is 100 liters and the present amount of moisture present is 20 liters, then relative humidity is 20%, right? And now it has increased to 50%, right? So if let's say if we add more moisture and we keep adding more moisture, right? Now what is the total carrying capacity at this temperature? 100 liters. Okay, let's say it is 100 liters. And when we keep adding moisture because of evapotranspiration, the amount of moisture in the atmosphere keeps increasing. Then there will come a point when the overall moisture present in the atmosphere will increase from 50 liters to 100 liters, right? Now tell me, what is the relative humidity? Now relative humidity is 100%, meaning the air has become saturated with moisture. The capacity is 100 liters and the amount of moisture present is 100 liters. Hence relative humidity is 100%. It means this atmosphere cannot take any more water. If you add any more water to this atmosphere or this volume of air, then it will spill out. What is the meaning of spill out? Meaning this extra amount that you are adding. For example, let's say after 100 liters, you added 20 liters more. So this atmosphere cannot hold this 20 extra liters. So this 20 extra liters has to be shed. And how that happens? It rains. Right. So the extra water beyond the capacity will have to be removed, and that removal happens through precipitation. So this is what we mean when we say relative humidity is 100%, meaning it cannot hold any more moisture, meaning it is going to rain. And the point meaning the temperature at which this relative humidity was reached, this temperature is called as dew point. Getting it? So this temperature at which, so dew point is actually the temperature at which relative humidity reaches 100%, and any more moisture that you add will spill out in the form of precipitation. Okay, so let us understand this even better. Let us say this bucket represents atmosphere. So this atmosphere at a given temperature, let's say 40 degrees centigrade, has a certain capacity to hold moisture. And if you keep adding moisture at that temperature, then there will come a point when the atmosphere is full, meaning it is saturated with water or moisture. It cannot hold any more moisture because it has reached the saturation point, right? So any more moisture that you add will fall off as rainfall. So how to reach the dew point? One way to reach the dew point is to add moisture to the atmosphere. But the temperature has to be kept constant. Now this is a very important point. Why the temperature has to be kept constant? Because in the beginning here I told you, if you increase the temperature, then the water holding capacity of the atmosphere increases. So on the one side you are adding moisture, but on the other side, if the temperature is also increasing, the capacity is also increasing. So RH will not increase. Relative humidity is what is the total amount present to the total holding capacity. So by increasing the temperature, you are increasing the holding capacity of the atmosphere. So you are adding moisture, but this is also increasing. So relative humidity may stay constant. So one way to increase or one way to reach the dew point is by keeping the temperature constant, right? Temperature has to be kept constant, and you go on adding moisture, and there will be a point when the atmosphere reaches saturation point and extra moisture will be shed off as rain, and the temperature at which this happens is called as dew point. Got it? But there is another way through which we can reach the dew point without actually adding moisture. Can you guess it? How can we do it? Yeah. So we can do it by decreasing the temperature. By decreasing the temperature. So let me explain this to you. Okay. Now I told you that a given volume of air at a given temperature has a certain capacity to hold moisture in between the spaces. Okay. Let us take one example. Let's say this is the volume of air and the temperature is 40 degrees. And capacity to hold moisture is 100 liters. Let's say this volume of air can hold 100 liters of water. Okay. And if I say relative humidity is 50%, it means capacity is 100 liters, current moisture is 50 liters, right? Relative humidity is what is the present amount divided by holding capacity. So holding capacity is 100 liters, present amount is 50 liters, so RH is 50%. So the present amount is 50 liters. If we decrease the temperature, okay, let's say we go from here because of the fall in temperature. Let's say suddenly there was a cloud cover and the overall temperature. This is how it rains, right? Before rain, you see the temperature of the area decreases, right? And at the same time, moisture is also being added. So temperature decreases. So because of decrease in temperature, the overall holding capacity or carrying capacity of the air decreases. So the space has decreased. So temperature has gone from 40 to 20 degrees. Now because of temperature drop, the holding capacity at this temperature was 100 liters, and because of drop in temperature from 40 to 20 degrees, the holding capacity also drops, right? Because the area has shrunk. So let's say the capacity now is just 50 liters. And here we saw that relative humidity was 50%, meaning there was 50 liters of water. And because of decrease in temperature, what is the new capacity that of this volume of air? 50 liters. So the capacity has shrunk to 50 liters and the amount of moisture present is also 50 liters. So the relative humidity is 100%. See? So because now the relative humidity is 100%, any extra moisture that you add into this air, or if the temperature falls even more, the capacity will fall even more. So the capacity may decrease from 50 to 40, and now the relative humidity has gone beyond 100%. That extra moisture, because of the drop in temperature, will fall as rain. You can use this analogy. For example, this was the earlier capacity of this sponge, and because of drop in temperature, the capacity is decreasing. The size is beginning to get smaller. Here it is even smaller, and at this stage, the extra water will come out because this sponge cannot hold even extra water, and it rains. So now what is the dew point here? 20 degrees centigrade, because the 100% relative humidity was reached at 20 degrees centigrade. Right? So, to recap, what is relative humidity? The basic definition of relative humidity is what is the total, what is the total amount of water present, to the total holding capacity. This is the formula. So, what is the holding capacity and how much the water is present, and it is expressed in percentage. Okay, if relative humidity is 20%, it means 20% holding capacity has been taken up. 80% is still there. Matlab, you can add more water to this air before it reaches dew point. right? Dew point is basically simply the water cannot be held anymore. It has to fall down as rain, right? So that is relative humidity. And what is dew point? And dew point is basically the temperature at which relative humidity becomes 100% and water cannot hold any more water. The air cannot hold any more water and extra water will fall down as precipitation, right? Now you might wonder why this is called as dew point, and it is simply very clear. In the morning when you get up, you see dew drops, right? On leaves, and if you have a car, on your car or on other objects. So why the dewdrops have accumulated? Because at night temperature went down, so in the morning temperature is lowest, okay, of the day, and the capacity of the atmosphere to hold moisture has shrunk. So the relative humidity has reached to relative humidity has reached 100%. Hence, the moisture has collected in the form of dewdrops, and that is why it is called as dew point. So, how can you reach dew point? There are two methods, right? There are two ways in which dew point or RH can be made 100%. First, you keep the temperature constant. We kept it at 40 degrees, and you keep on adding moisture. So, RH will be 100% and the temperature is the dew point. Otherwise, you don't add moisture but keep dropping the temperature. You are basically reducing the total holding capacity of the air. Then also there will be a point of temperature where relative humidity reaches 100%. So whenever the relative humidity reaches 100%, that temperature is called as dew point, and then precipitation happens. Right. So this is how it works. I hope I have been able to explain it to you in simple words with proper analogy. And if you have understood it, well done. Otherwise, you can revise the video and watch. And if you have any doubts or any questions, then please, put them in comment section below. And if you like the video, then please share it and prepare well. And until next time, take care.